But our game plan is tonight is we're going to I'm going to introduce our guests, which are the people that really made this program possible and made it happen. And after we'll have a brief presentation from Jordan Lee, who's the chief engineer on the powertrain. We'll talk a little bit about the engine, and then we'll introduce a couple of the other folks that were involved from the design and styling side of the house. And after that, we'll open up the questions for the audience. So it's going to be a free-for-all, so you can ask all the questions that you've never been privileged to learn the answers to in the past. So as you're coming up here, I wanted to introduce the people that really make this possible, and that's Paul and Gary Stanford. They sponsor our chapter and treat us lavishly. And if it wasn't for them, there's no way we could do the programs and activities that we do.
We had the unveiling today at the dealership, which I'm sure a lot of you were there. And we had people lined up at 7:30 in the morning waiting to go for the doors to open. And I think we probably estimated about 1,000 people that saw the car. You couldn't hardly get around the car from the amount of people that were there. I think they wore out the seats from the amount of people that sat. But truly an unbelievable car and an unbelievable value. I think that's the proposition that Corvette has always had, that it's been the affordable sports car that what it is. And to see that car in person, to see all the people, just the looks on their faces and the expression, I would have to say that General Motors hit the ball out of the park.
You know, we've seen the introduction of the C4, C5, C6, C7, but we've never, ever seen the kind of interest that we saw today with the interest in this new C8 Corvette. I mean, it's just unbelievable. It really has been. So those of you who have stopped at the dealership today, we appreciate it, but it has just been a wonderful, wonderful experience, and to see this interest level is phenomenal. And I got to thank this team over here for a masterful job in designing, engineering a magnificent automobile that's going to blow the doors off Ferrari.
I'll tell you something, if you don't want to, here's my own prediction. I happened to have lunch, the privilege of having lunch with Mark Royce about 2 weeks ago at the employee car show, and he asked me what I thought of the new car, and I said I was really blown away. What I was really surprised about, mid-engine cars tend to not have much leg room, and the C7 had no headroom, so I thought I'm done buying Corvettes. Thank God I got a bunch of old ones I can use. But the new car, it does everything right, with the exception of one thing. Those of us that own C6s and C7s are going to take it on the chin really bad. So I guarantee you'll be able to find some great deals on past model cars at Stanford Chevrolet if you're so inclined. We weren't planning on doing any other formal programs. We just opened it up for questions, but maybe it'd be worthwhile for Kirk or maybe Josh going to talk a little bit about what this is a dramatic change for an engineer to build a car that's this radically different. The polar moment inertia is so much less. So all the engineers knew for years that this was the way to go, yet nobody ever did it. So maybe you could talk a little bit about what were the enablers that made this happen now, and that'll get the questions going. After that, I'll sit down, shut up, and let you guys vet. So.
All right, sure. Thanks, Warner. Again, my name is Josh Holder. I have my dream job getting to work on this car with this team. I grew up in northwestern Montana. My dad bought a Corvette when I was a kid, and got to go to car shows with him and join the Corvette Club. And all he would let me do was polish it. But I knew someday I wanted to work on, not just specifically work on Corvettes, but to be an engineer on Corvettes. And to get to do it now is truly a blessing, especially now, making history that we've done with this car. And just a couple of comments to follow up on what Jordan said. This engine is awesome. We just finished what we call our 24-hour track validation. I'm not sure I'm supposed to be telling all you guys this, but I'll give a little inside secrets. So we are brutally punishing on cars. We do stuff to cars that you guys would cringe at. And one of those tests is to take this car around our Milford road course flat out. And we have some super, I'm going to brag about our development team, super capable drivers that could fit right in any race team. They're extremely capable drivers. Take this car around this track for 24 continuous hours. The engine's basically singing close to red line the entire time, delivering full torque the entire time, punishing thermal environments. I would challenge anyone in the room just to ride as a passenger for an hour in the car and imagine all the systems in this car that have to live up to that punishment for 24 hours. The engine not only made it through, didn't burn a drop of oil. We, set the times for the track that we wanted to set. It's just a small testament. That's just one sliver of work that we do, but a testament to what Jordan and his team have done, and to make an engine that delivers this much power, which, by the way, they are notorious sandbaggers. We were pleasantly surprised by the power output. I think people are getting a little spoiled by this is the new golden age of horsepower. And so I've heard a few comments, man, you're so close to 500. Like 495 horsepower, if you divide that by the displacement of the engine, the specific power output, it's unheard of. Way more than the LS7 or legendary LS7. This engine delivers way more specific power output. It's built at Tonawanda at a high volume plant, so it's affordable, and it's one way we can deliver a car like this that does 0 to 60 in under 3 seconds for under $60,000. That engine's a big reason why. And so, again, just to be a part of this team, this car now, I can't wait for people to get to drive the car. A number of us have been able to spend time in cars. And when the media gets a hold of cars, you're going to see some pretty impressive articles, I'm confident of. But when all of you get a chance to drive the car, it's unlike any Corvette that you've ever driven. The command view of the road, out the windshield, just, you're not used to seeing this big hood in front of you. You can see the pavement. Your feet are literally on the front tire. Mm-hmm. And to be able to apply throttle in this car and have the car respond, transmit that massive power and torque to the road the way this car does is something like those of us that have driven Corvettes for years are certainly not used to. And the car is supremely capable, and we're all very excited for people to get to experience it.
I don't see any hands going here, so I'm going to ask Kurt one that I want to know. You had to deal with all these other engineers with all their priorities. I mean, what was the biggest challenge? You can complain about some of your idiots you got to deal with or whatever, but what was the biggest problem you saw? I mean, I know you guys have this concept, what do you want this car to look like? And you end up having to, compromise it because it's the demands of the engineering community. So what was your biggest challenge?
Well, there's a few metrics we're always baking in. It's low drag, cooling, lift, things like that. I would tell you, for Tom and I, we always kept focused on design. We were a big part of, this is a new animal to us. So we probably had 3 full sizes going, a design on each side. So we'd have 6 designs going full size, because we want it to be the best car possible. But in doing so means we looked at a lot of theme work. We did a lot of that. And while doing that theme work, we're challenged on other fronts with there is lamp packages that are involved, and that headlamps are like icebergs. You only see about this much, but they're much bigger below. And that probably the hardest metric to get to was the cooling. Because we were managing. The car now it's gone from a single radiator car to now a 4 heat exchanger car, where the outboard corners, we spent a lot of time because we're taking in air to get it through a heat exchanger or a condenser, get it through the wheel opening, get it around the brakes, and then out again. And for Tom and I, we had some late nights at the wind tunnel where we were messing around with those corners. They're real sensitive, and I'd say no less than probably 50 changes on those front corners. of just carefully massaging, tuning, and we would do that by hand in the tunnel. I mean, you could do some of it in math, but to kind of get there, you had to do it like real time. And where you just had to model it, hit the switch, run the tunnel, let us see what we got. And so we did a lot of that throughout the whole car in refining that proportion.
I have to point out something that may not be so obvious. These two are incredible to work with. What the secret to the success of how they integrated all the engineering difficulties into a design that works is they were welcoming, and I'm sure they operate the same way with the vehicle folks. They bring the engine folks and they explain to us what they want. When you understand what you're after, it's so much easier to come up with a solution that works for both aesthetics and the engineering portion. So their ability to really gather the team together and integrate them and make you feel like you're part of their team, that was the secret.
Well, I mean, we all know about Tom. I mean, everybody that that's an NCRS member, a National Museum Committee member, or a lifetime member knows that Tom is going to be inducted into the Hall of Fame. I forgot to mention that in his introduction. You know, his accomplishments are well known and documented. And it blows me away. I don't know what I was going to ask you what the CD ended up with the car, because I can't believe that you can make a car that looks that good, that's aerodynamically, appropriate for today's market. Because it looks to the older cars to me, I know that the big fat tail ends on all of our C's, 5s, 6s, and 7s was all a result of aero. And this car is spectacular. And my compliments. And what is the CD for the vehicle?
Well, we haven't advertised the CD. I will tell you, in its efficiency, it's just as good as the previous car.
Okay.
And that as far as the CD goes. The difference is, the C7, has a small opening in the front, and that only attributes to so much drag, whereas this one, we're taking in air in 4 key areas of the vehicle. So if you just looked at the shape, it's very efficient. If you add the cooling metric, then yeah, we do take on a little bit more drag for the cooling efficiency.
It still goes 194 miles an hour, so the drag is pretty good.
495 and 194.
You won't notice it.
Yeah.
How can we get by with just that? Tom, you must be like a proud parent sitting with it.
Yeah, but I mean, just what Jordan said, and Josh and Kurt, you mentioned compromises. I got to clarify two things. One is because the engineering community is just phenomenal. I'm really a designer. I'm really formerly known as kind of engineers, maybe worst nightmare, because the difference is designers, particularly, I'm speaking for myself, and I have a total disregard for physics and budgets. This car is successful for probably many reasons, but to me, primarily, it is the people. When we talk, and I think the powertrain, the collaboration around that is just, we've always had a strong passion and collaboration for Corvette, and that's why it's been successful. It's not any 1, 2, or 3 people, it's thousands of people that get involved with this, cars like this. And can you imagine just building that concerted passion, level of passion and expertise and knowledge? And we haven't really mentioned even the race team. When we started the C5R, Herb Fischel kind of had a vision for that. And I tell you, everything now you could look back on, it's all kind of aimed towards this sensorial, this culminating into this car. So not only do you have people that are directly involved, you got people that go all the way back to the 50s that have worked for this point in time. So that's pretty magnificent and wonderful to be part of that. But the collaboration was awesome. We talked, Gordon talked about coming to the studio, and I just felt it was imperative that the only way to meet customer expectations and deliver what folks want, and where we know our competition is going and the world that's out there, we all have to be together, because it isn't just someone hammering one vision. That car is beautifully executed and elegant, and right down, Jordan mentioned every nut and bolt, the finish is just unbelievable. What struck me here looking at these slides is it's powertrain, it's metal and it's plastic and some other probably exotic materials too. But what struck me is it looks more organic. It looks like a human, almost like, it looks like a heart. Kind of reminds me of that, you know, it is, the engine's really a pump, but it's becoming more sophisticated and elegant and simple, yet super high performance and dependable, just like our bodies are supposed to be. You know, that's kind of weird. It just kind of struck me now, you know. And to me, that is, I mean, the human body is ultimate in design, period. In engineering, it's amazing. So I think we strive for that, maybe not directly, but indirectly, you know. I mean, it's amazing. You know, bringing in the race history, and Kirk mentioned the aerodynamics. When we first started, it was probably like, man, do we have to do that? I remember hearing quotes from Bill Mitchell saying, you know, it's a shame that physics go that way, you know. But I think it was somewhere along the line, I don't know, it was probably, I gotta say probably C6. It kind of struck me, you know, when it's like, one night I think when it was dark and quiet, you know, it's like, you know, rather than trying to reluctantly get engaged with aerodynamics, let's embrace it, just like with these other aspects of the car development, and collaborate. And you know, it really started to flourish on C7, I think, what we learned directly from race, you know, the race. I think it's what really illustrated for the first time was what they're doing in the race program. You know, like just the one that sticks out is, you know, taking the radiator and just flipping it, the right way so the air flows through it and then in and out, right? From the race program, and then air coolers on the rear quarters, and everything else goes along with it. You know, the corners of the cars, all that, the profile. Like the mid-engine profile is probably quintessential optimized shape for aerodynamics. So that's a big win right there, just by virtue of the proportions. But embrace that you know, the aerodynamic requirements and factor that in. And what we found is that it affected the aesthetics, the way it looked, certain elements of the car looked, that we may not have come up with just by sketching it as design and styling, you know. And what that does, it makes it even more genuine, and the customer and people, and certainly the people that drive it and are looking at measured metrics, really appreciate, you know. And that's how we achieve that. If that makes sense to you all, you know, I got to tell you, that's the truth. And so we've worked really close together on past Corvettes, but nothing like, it's kind of like the horsepower curve on the motor. It just ramped up hard, and you know, we have all this technology available to us, and it's easy to, you know, do whatever you can do on the computer, then push the button, it goes to, you know, Pontiac or you know, just over within the tech center. But we felt it was really important to get together face to face, and that was the fastest, most direct way of communicating perspectives and addressing challenges right away, and then moving on to the next thing. And you know, it was not easy, but it was just magnificent to be part of that.
So Tom, I can just envision how long this process has been going on for years, right?
60 plus.
And I just wonder if you took maybe the mid-engine Ferrari as an example and looked at that car, did that give you any inspiration to do the amount of detail and refinement?
We looked at all, you know, I mean, we knew that we're entering into a different realm here. And Jordan and his team has heard me say it among anybody that came and said, look, I mean, we've all strived to create a better Corvette each generation. But this is different, and I kept saying, this is an exotic supercar. And you have to understand what that phrase means. And I admit that I'm not even sure I really did, but we did our best to study these cars. I mean, there's pedigree there that goes back since day one, you know, back into the 20s and 30s, you know, with these vehicles, and we're kind of a new kid on the block. So you have to understand that. And I know we had a couple of Ferraris available to us, and you know, experiencing them for everything, you know. And some of them, quite frankly, were, you'd be shocked at how they're put together and the lack of attention to detail, but the overall effect is obviously stunning on a lot of it. I know you guys looked at some of the powertrain stuff, see if there's always something to be learned. Even if something.
You know, to your point, the race team and how they did their powertrain, a lot of different materials, and that we also Tom said we brought in motorcycles as well. Looked at some high-end
Yeah,
Ducatis.
good point, yep.
And
That's what was really a good point, because the level of detail, Tom provided.
I think the best thing about it is that it's roomy and comfortable. I'm not sure if Spielman was there, but his voice was heard. I was teasing Joe, and Joe Thomas says you're standing in line down at Stanford's dealership. I says, you got a bottle of KY jelly there, you're gonna apply to fit in this thing? Joe's about, he ain't that big, but he has snow on his shoulders about 6 months out of the year. So, but he fit right in. I mean, I'm thrilled. I mean, I'm a buyer.
Probably talked about.
Well, we could thank Ed Piatek, 'cause we'd have Ed get in the car, and he had to wear a helmet.
Yeah.
And he was kind of the bogey, but we were pretty far along with the car when we brought Spielman in. And we had him sit in the car, and it was emotional for him. You could see tears in his eyes. He couldn't believe that he could fit in it. And
Was that by design, or did that just come about because of the mid-engine platform that the car became a little bit roomier?
it was intent. It was definitely intent, yeah.
Well, thank you, I appreciate it.
Dan?
Yeah, with the placement of your body now in a different location in the wheelbase, how does that feel when you're driving?
I touched on it a little bit. I think we all came just sitting in the car, but my impression again, it's like it's been brought up. It's like you're sitting on the tip of a rocket, right? You got all this authority behind you, this powerful engine behind you, and
you're
no
turning,
instruction. So
stuff.
when you
Feel.
move the car dynamically, now if you think about where the center of gravity is, and we have some diagrams I can show this, but the center of gravity is, look, you're sitting on it now.
Yeah,
And so you feel like the car rotates around you.
around you, yeah. 'Cause
Even
you're
at the
sitting in a
limits
different
of
location.
capability of the car and yourself.
Yeah.
For example, in a front engine car, especially a big horsepower front engine car, if you're in a turn and you're a little too judicious with the throttle and you start to lose the rear, a couple of things happen.
Right.
Not only does the rear step out, but you transfer all this weight to the front. So now your steering input that you had before became that much more authoritative, and the whole car wants to rotate around. This car, even if you do start to spin the rear, you don't get that weight transfer. We've already got the weight at the back of the car. It stays at the back of the car. You can drift the car around an autocross course if you want. It's certainly not the fastest way around the course,
Yeah.
but it can make you a much better driver than you might be in an otherwise front engine car. It's just super, super fun to drive.
Yeah. Oh, another question. Is the crankshaft in the LT, was that crankshaft lowered in the block?
No.
It's in the same location?
Same location.
But the whole powertrain is an inch lower in the car,
Yeah, because of the trans.
thanks to the flat oil pan and a bunch of other things.
Yeah, Joe?
Question about the motor sitting behind you now. What was done to keep the interior quieter? Or was that big of a problem, moving the motor from the front to the rear?
It was. We did a lot. Frankly, we were super paranoid about it.
Okay.
But when we first built our early mules and prototypes, Corvettes want to be lightweight. Sports cars want to be lightweight, so we value mass very highly. So we went in with a conventional construction, knowing that it probably wasn't going to be good, and it was not. From there we developed what we had to do to construction on the seat back. We've actually got 2 layers of aluminum. The glass behind your head is 9 millimeters thick.
Wow.
And every 1/10 of a millimeter was thought about because glass is heavy. And so I think with the recipe that we put, separating the occupants from the engine, all you hear is what you want to hear. Typically, you don't want to hear a belt or an accessory drive or an injector ticking. Instead, you want to hear that sweet exhaust note coupled with a little bit of induction, and that's exactly what you get in this car.
Thank you.
Yeah, Carl?
You mentioned that there was a previous LT2. What's the relationship between this one and the previous one?
The name, I
Just
guess.
the name, just the name.
Yeah, the LT, their old one was a big block.
Okay, we're gonna just,
Yeah.
question about the frame, which has really changed from the C7. I mean, you went with aluminum, carbon, laser welding, no more MIG welding. How was it was it a lot lighter frame than the C7? And how was that technology evolved into that?
Yeah, the frame is a little lighter than the C7, but I would say where we were really afforded some technology was in our high pressure die castings. So like you said, we have an aluminum frame on the 7th generation car. We continue that into this car. We used more structural adhesive. Those are augmented, each one of those joints, with what we call the flow drill screw to keep that joint together, so that can transmit a lot more torsional load. Makes the frame stiffer. The high pressure die castings that we're doing internal, we're not buying them. GM is making them in Bedford, Indiana. Our industry first, they're the largest high pressure die castings ever produced. And we have them in this car. They're one of the things that keep it really stiff, really light. They also keep costs down. We integrate a whole bunch of what would otherwise be complicated parts to do that same job in one casting. And then the center tunnel, we're a tunnel dominant structure. If you think about a mid-engine car and how you have to manage like crash loads, a front crash load. In a typical car, that's managed around a rocker. In a mid-engine car, that path, if you were to look down on the frame, is very tight. And so if you think about all that force going in, trying to transmit into a rocker, it's a very inefficient path, because again, your feet are right on the flap of the tire. So in the C8 aluminum frame, we manage those crash loads down the tunnel. If you just to look at the interior, you can see the car, well, it still has a tunnel. There's no drive shaft in there. Why do you guys have a tunnel? Well, that's our center backbone. And now that we have an electronic shifter, we don't break it up with a big hole that we would have to put in there for a manual transmission, so that becomes a super efficient load, especially for an open roof car.
Been well publicized that with the engine power, frames were being bent and you had to regroup. Can you speak to what part of the frame was bent and what was done to fix it?
Yeah, I can, because that rumor was so preposterous.
Yeah.
We just let it keep going.
It's
It was kind of
Yeah.
awesome.
Came a distraction.
Car was bending in half, doors are flying off.
But it was kind of cool urban legend, so
Yeah.
we just left it at that.
We heard about it, and I think I talked to Josh and said, hey, sorry about bending your frame.
If you think about the way loads had even be transmitted, that would be impossible to do. It still makes for a cool story. We think what happened, we don't know this for sure, but it sounds like the first time it was written about, there was, we were sharing a track at VIR with some, not just us, with other GM programs. There was a piece of camo taken off a different car, it wasn't even our car, and it got reported that we crashed a car, we did not. And then there was a piece of glass that had been removed, I think it was a windshield from a different car, and it got broken in the process of putting a dumpster. And so we think some dumpster divers, after we left,
Yes.
went through, found these parts, and it just fostered this.
Yeah, what's the capacity of the fuel tank and where's it located?
The capacity is 18.5 gallons, and it's located behind the seat back, much the same as the current Corvette. Of course, relative to the driver, much the same, in a completely different environment. Obviously, in this car, we're packaging it around an engine and some other components that get hot, which is not what you want to happen to a fuel system. So there's a lot of specific engineering and development that went into it, but it's 2 saddlebag tanks, we call them.
Same way that would.
Yeah, same way. The biggest difference, I would say, in the way it's packaged, if you were to look at the 2 side by side, the crossover that separates those 2 tanks is now at the bottom of the tank instead of the top of the tank, like it has been since C5, but otherwise packaged in much the same place.
You've got a big rear window over the engine. Did that complicate the cooling of the engine?
Somebody else take it.
It took us a while to figure out what was the best material we could put over the engine. You know, we had the glass, but what's surrounding the glass is what we came up with. It's an SMC component. It's a sheet molding compound. You know, it's a modern fiberglass basically, but because where the heat's coming from, rising from the headers, and that it's, you know, it's outboard a little bit. It took us a little while, like I said, to figure out what material could actually live back there, and then we had to figure out the area of each opening.
The
and
pathway.
get the right amount of convection from the engine through the vents in there.
Yeah, what kind of camshaft do you have in that car?
The engine. What kind of camshaft do you have in the car?
It's a steel billet.
Steel built, so it's a roller cam.
Flat tap or a roller?
Roller, definitely roller.
Yeah, roller.
No solid lifters?
No.
Like tapping cams.
30-30 cans? My favorite sound.
Okay, yes, Tom?
I'm assuming it's a GM transmission, but is that a GM
No.
transmission?
Well, we developed it in partnership with Tremec, but the transmission is manufactured by Tremec. It's actually final assembled in Wixom, Michigan here. But yeah, that hasn't been talked about a lot, but that is our dual clutch transmission. It's part of what enabled the whole architecture, honestly. There's a lot of consternation about the fact we don't have a manual transmission in the car. This is our one and only transmission. But when people get a chance to experience the car, the lightning quick shifts of the this is not like your paddle shifting automatic. It's something totally different. It does behave much like a manual transmission does. I have manual transmission cars. I'm a manual transmission fan, so I was a late adopter, but I have embraced this. It's super awesome. And we've done a few things like the tap paddles, for example. If you pull both of them, it puts the transmission in neutral, so you can rev the engine and maybe do a big smoky burnout if you so choose to do that. But it's very engaging. If you don't want to deal with a manual transmission, it will behave much like an automatic. You can put it in drive and not think about it. And of course, it's always a better, no matter how good we think we are at shifting, the transmission's faster than we could ever possibly shift a manual.
When we experience these different cars, these competitive cars, i.e. Ferrari and all that, one thing that I know, so I'm a stick shift guy too, you know. Might be a generational thing, probably is. And it seemed to me up to a certain point, paddle shifts were kind of cool, but to me they were kind of like, unless you weren't on a high-speed raceway, they were kind of a novelty. And I just, whatever, I just went back to stick. But when we drove some of the cars through the Ferrari and being in that position where, instead of driving the car like this, you're like up here and you're engaged in a car, you're part of the car in a different way than we're used to. And the paddle shifter on the Ferrari, that configuration just seemed far more natural in the way it behaved, which is different than the way we've typically done them in the past, and how it coordinates with the accelerator pedal and all that, how the car reacts. But it just seemed more natural, more appropriate for a forward-looking vehicle and a mid-engine supercar to have that high-tech interface to shift the gears. To your point, you can't match it. So I think there's trade-offs where you might think you missed a shifter in that, and once you get in the car, you say, you know what? This feels more natural, more advanced, more, whatever you want to say it, futuristic, just more correct for the configuration of the car, if that makes sense to you. I think you'll agree. Because boy, I tell you, I'm a diehard too,
One more question for Tom. I don't know if you can answer this 100%, but I'm going to ask it anyway. Chevrolet's been building front-engine Corvette since 1953 for 7 generations.
Yeah.
One day, somebody came up with the idea, and Zora goes back to the 60s, obviously. Yes. Mid-engine car, we need to build one, right? Somebody came up with that idea one day, was, so we're going to do this, right?
Yeah.
How long ago was that somebody got that clean sheet of paper and let's do this thing?
Let's do this.
Yeah.
I know it's towards, and correct me if I'm wrong, towards the end of the development, or involved in the development of probably the ZR1, and knowing that was the pinnacle of what we could achieve performance-wise, everything-wise with that architecture. And I've in my career, I've been involved with and witnessed numerous occasions when the mid-engine was put forward to go forward. And I remember clearly, when Dave Hill was chief engineer, no, we're not ready, we're not doing it, blah, blah, blah. And because he knew there was more headroom there, but I don't remember the day, but I remember Taj saying, we've maxed this out, it's time to go to the next level now. And we kind of went, yeah!
I mean, think about it, it's hard to pinpoint 5 years in the future, we're gonna do an all-new C9, and we're gonna launch it 5 years from today's date. And all the work that has to go into making it happen on the exact date. It's nearly an impossible task.
One last question. Your European competitors have the ability to pull out command modules or computers, have them reprogrammed along the theme of software for an additional 100 horsepower. Does the C8 have that capability? Just reprogramming for additional horsepower.
So we are gonna have software update capability over the air. We've talked a little, you've seen a little bit about the new architecture, you'll hear more about it. So the ultimate goal is to be able to make updates to your car, like I use the iPhone example, much like that, where we can even do it maybe without you even noticing that something happened. We want to try to do it in a non-intrusive way. I would ask Jordan if he's got a secret cal that unlocks 100 horsepower, but I'm pretty sure I know what his answer is. We tried to do a good job the first time.
You'd feel terrible if we had an engine that was capable of 595 horsepower, and we held it back from you. Unless you paid more. I think you pay enough, you know, you get all the good goods right from the beginning.